Okay, I'm doing this at lunch, so you're about to hear a ding in a minute, but oh well. Today we're going to talk about the tangent, which is actually a part of trigonometry. I'm going to try to make this as simple as I possibly can. You need to look here and make sure you understand what I'm talking about. This is the actual nuts and bolts of it. All right, the word ratio is a fraction, a comparison. That ain't my lunch. It's a comparison of two values, and it's talking about the sides of a right triangle. And more specifically, we're talking about the lengths of the legs in a right triangle. So trigonometry is math that's only concerned with right triangles, okay? That's our main concern, I guess, is our right triangles. And the tangent only deals with the legs. Remember, leg and leg are the sides that are not the hypotenuse, which is diagonally across from the right triangle, from the right angle. Okay, so what this really means, the tangent of an angle is the opposite side of the given angle divided by the adjacent side. Let's talk about these two words. Opposite. If I'm talking about angle 1 here, opposite of angle 1 is A. Adjacent to angle 1 is B. What does adjacent mean? Right next to. So if you think about angle 1, there's two sides adjacent. That's C and that's B. We know adjacent can't be C because C, that's my lunch, is hypotenuse. We always know what the C is, so the only other side that's available as adjacent is B. But that changes for angle 2. So here's what I want to do, is I want to kind of put those two together and talk about it. If I'm talking about the tangent of angle 1, okay, I'm just letting you know where this is coming from. What I would say is A over B, okay? But if I'm talking about the tangent of angle 2, that would be B over A. And so you notice automatically how they differ. They're still the same ratio, but it's opposite for this angle and adjacent for this angle is different than opposite for this angle and adjacent for this angle. We never worry about the 90-degree angle. It's always the acute angles, okay? Not the 90-degree. What is acute? Less than 90. So it's always the angles that are connected to the hypotenuse, so to speak. All right, so how do we actually use this? Here's an example of how we use the tangent. All right, so let's take a look at that. If I'm looking at this example here, they want me to find the tangent of S and the tangent of R. Okay, so I want to say tan, notice how I'm writing it, of S equals, the tangent is opposite over adjacent. Okay, so that's 80 over 18. Now, you always look to reduce. You always look to reduce your fractions if you can. So 80 over 18 reduces to 40 over 9. What about the tangent of R? Well, the tangent of R is going to be opposite over adjacent. So that is 18 over 80. And since I already know what this is simplified, I'll just, change them up a little bit. And that is the tangent of R. Okay? Now, let me show you how we would use this some more. We have this problem here, and this problem here asks us to find the value of X. And in order for me to set that up, based on what I know, I'm going to use the tangent. What do you mean based on what I know? I know this angle here, I know the opposite side to that angle, and I know, or I'm looking for the adjacent side. So I know everything I need to know. Let me say that again. I know the angle, I know the opposite side to that angle, and I know the adjacent side to that angle. All right? So how do you set this up? Well, let me show you. You would say the tangent. Now we don't have to have R or S or something like that like we had. We actually have the number. So it's always the tangent, and normally, oops, that should be a 3, you will put that in parentheses. You will put your angle value in parentheses. Equals opposite over adjacent. The tangent of 32 equals opposite over adjacent. So far, notice what we did. Angle 1, angle 2, always what's right here on all these is the angle, okay? But now we actually have an angle value, and so that goes right there, but we want to put that in parentheses. In fact, if you use your calculator and you push the tangent, which is this button here, notice it already opens it up for you. It's telling you got to put a number in there and then close it up. All right? So how do we solve for x? Well, we're going to treat it as a proportion. I think it makes sense to always make it a fraction and then cross multiply. So that is x times the tangent of 32, and that's all one thing. The tangent of 32 is all like one number. So x times that, I just put x in the front, equals 11 times 1, which is 11. Okay, so what did you do, Mr. Freeman? Oh, thanks for asking. I cross multiply this times this, and it just equals that, and 1 times 11. In order to solve for x, I have to divide by that. Why? So you can get that by itself. And so I'm left with x equaling 11 over the tangent of 32. So that is something that you actually can put in your calculator. All right? So I'm going to do that. I'm going to say fraction button, 11 over the tangent. I just hit that button, and I'm going to say 32 and close it up. Enter. And that means x is approximately 17.6. This is the way that we're going to use it most of the time, is to find a missing side. But I just want to show you one other thing. If we could go back to this problem here. All right? If we can go back here, that's the tangent of S, tangent of R. Sometimes we need to know the angle of S, the actual angle degree measure of R. You can actually find the angle based on the ratio if you use what's called the inverse tangent. The inverse tangent looks like this. It's actually written tan to the negative 1. That means inverse. Negative 1 power in math always means inverse. Now, if you actually look at this, if you look at the button on top of tan, you see that tan to the negative 1. What it's saying is you can use this to help find an angle. How, Mr. Freeman? Well, thank you again for asking. Say we go back up here to this example. 40 over 4 is what S reduced to. All right? I'm going to hit second and tangent, which gives me to the inverse tan. You see how it's tangent negative 1 here? And then I'm going to put in 9 over 40. Close it up and then hit enter. So that means my angle is approximately 12.7 degrees. So if I wanted to know the angle S, it's approximately 12.7 degrees. Okay? It works that way. You can actually use what's called the inverse tan to find the angle. How do you use it? You gotta make sure you use the inverse button. How do you get there? On almost every calculator, you gotta hit second to get to it, and it's usually right on top of the tangent button. You only use that button, the inverse, if you're looking for an angle. Otherwise, you leave it alone and just basically hit tangent. All right? Let's see if we can do something else. All right, so here we go. I want to do a couple more. Ugly drawing, but you get the point. Notice what I'm looking for if I'm solving both of these for x. On this one, I'm looking for an angle. On this one, I'm looking for a side. So the only thing I know so far is tangent, but since I'm looking for an angle, I automatically know it's tangent to the negative 1 power. I'm using the inverse tangent. Okay, how do I know when to use the regular tangent? Like I would use down here, I'm going to use regular tangent down here. Well, I use the inverse tangent because look where the x is. It's already talking about an angle. Look where this x is. It's talking about a side. You have to know the difference, okay? You got to know when to use inverse or the regular function. So here, you still set up the ratio. It's opposite over adjacent. So this would be 8 over 5. I'll put it in parentheses because that's what your calculator is going to do. So if I go to my calculator and I push inverse tangent, right? His second and then that tangent. And then I can use the fraction button if I wanted to, or I could just use divide. I could actually use divide if I wanted to. Enter, and I get that that equals, or is approximately equal to, let's just say 58 degrees, because I didn't tell you how many decimal places to go. All right? That's the inverse tangent. But notice I can use the tangent because I know the opposite and the adjacent. All right? If you are perceptive, you'll notice that tangent is not the only one that's right there. There's two others, but right now we're only focusing on the tangent. Now, I already said on this one I'm using the tangent without the inverse. Why? Because I'm dealing with the sides. Okay, that's very important to know. So you got to think before you actually start doing this. What am I trying to find? A side or an angle? In this case, the tangent of 64, remember the angle always goes next to the tangent here. Not necessarily inverse tangent, but the angle always goes next to the tangent. The tangent of 64 in parentheses equals opposite over adjacent. All right, opposite of this is x over adjacent, which is 7. Adjacent means right next to. Cross multiply, you get x times. Now put your number in front. I always say put your number, if you got to cross multiply like this, and it's a number here, put it in front of your tangent, because I promise you, you're going to make a mistake and put it behind here one day, and it's going to end up inside, because this times 64 is not the same thing. All right. So what I'm going to do is grab my calculator, and I'm going to say 7 times the tangent of 64, and then that gives me x is approximately equal to 14.4. Again, I didn't tell you how many places to go. Notice I didn't put a degrees on that because that's not an angle. It's a side. All right. That is the tangent ratio, and it's only used in right triangles, and it's only dealing with the opposite and the adjacent side. A quick note, many times I think about using the tangent whenever I don't have anything over here for the hypotenuse. If the hypotenuse is not in play at all, then I'm thinking tangent, meaning there's no x here, there's no number here. But that's not always going to be the case, because look here, I have a number for all three of those there. But consider the tangent when you definitely know the opposite or the adjacent, and you need to find the opposite or the adjacent. As long as you don't have to deal with the hypotenuse, then the tangent is at play. All right, if you got any questions, don't ask me.